Hello, everyone. Welcome to another hangout with your favorite interview buddy. This is the first lesson in the Data Structures and Algorithms Simplified series. In this series, we will be simplifying data structures and algorithms, understanding the basic data structures, the basic algorithms, learning how to implement them, learning how to use them, and learning when not to use them. This is lesson 1. Today's topic is what are data structures? We will be looking at the meaning of data structures, their categories, and a brief explanation of some basic data structures. Let's begin. Data structures are containers used to organize, manipulate, or store data in a computer program. They allow the computer program to access data easily and efficiently. You could think of them as a cabinet organizer that allows you organize your clothes in a way that it's easy to find a new outfit. There are two categories of data structures: linear data structures and non-linear data structures. Now let's talk a little bit about linear data structures. They are data structures that store data linearly or in a particular order, one after the other. You could think of them as data structures that store data on a straight line. Some examples of linear data structures are arrays or lists, stacks, queues, and linked lists. What is an array? An array is a fundamental data structure that allows you to store data of the same type in a contiguous block of memory. You could call the illustration below an array of humans. Arrays are always fixed in size. Each element in the array can be easily accessed by index, starting from 0. The next data structure we would look at are lists. A list is a data structure that can contain a group of elements of the same or different types. Unlike arrays, they are very flexible. Their size can change at runtime. You can append, update, or remove elements from a list efficiently. Next, we would look at stacks. A stack is a linear data structure that operates based on the LIFO principle. LIFO simply means last in, first out. Elements are removed or added from the top. Think of a stack of plates. You put new plates on the top and also remove new plates from the top. That is exactly how stacks work in programming. Next, let's look at queues. A queue is a linear data structure that operates based on the FIFO principle. FIFO simply means first in, first out. Elements are removed from the top or front of the queue and added to the back or end of the queue. Think of joining the queue at the bank. The person in front of the queue gets attended to first. New people join the queue from behind. The last linear data structure we will be talking about in this lesson is a linked list. A linked list is a linear data structure containing a sequence of elements typically called nodes, where each node contains data and a pointer to the next node. You could think of this as a long luggage train that contains different coaches joined together, each coach containing its own luggage and a door to the next coach. Or a scavenger hunt where each clue helps you find something and also leads you to the next clue. Or a group of humans holding hands together. Another category of data structures are the nonlinear data structures. These are data structures that do not store data sequentially, but in the form of a network. Examples of nonlinear data structures include trees and Graphs. Let's briefly define what trees and graphs are. A tree is a non-linear data structure that models a hierarchical parent-child relationship. It consists of nodes that are connected by edges. Each node has a parent but can have multiple children. You can think of this in the form of a family tree. Finally, we will talk about graphs. A graph consists of a set of elements called nodes or vertices connected by edges. Unlike trees, graphs can be significantly more complex, with one node having numerous edges or even completely disconnected from the rest of the graph. A graph could model a road network where the intersection of two or more streets are nodes and the streets are the edges. Now we have come to the end of today's lesson. Try to practice what you've learned today by answering the following questions. You can also rewatch this lesson as many times as you want till you are able to answer all questions confidently. Thank you for watching. See you in the next lesson where we will talk about arrays.